Question 17. A solid cone is joined to a solid hemisphere to make the solid T shown below. The diameter of the base of the cone is 7 centimeters. The diameter of the hemisphere is also 7 centimeters. The total volume of this shape T is 120 pi centimeter cubed, and the total height is y. Calculate the value of y. Give your answer correct to 3 significant figures. So what do we know here? Well, y is going to be the height of this cone plus the radius of this hemisphere. So we can write y is equal to h plus r. Now r we can find because the radius of this hemisphere is half of the diameter, which we know to be 7. And so we can write r is 3.5. So that's good, but now we need h, which we don't have at the moment. So let's work with our total volume for the shape, which is 120 pi centimeter cubed. Now we know that the volume T is the volume of a hemisphere, which is half the volume of a sphere. So that's 4/6 instead of 4/3 pi r cubed, plus the volume of the cone, which is 1/3 pi r squared h. We know the total volume to be 120 pi. We know our r value to be 3.5. And so we can substitute the values in to write the following. 120 pi is equal to, on your calculator, 3.5 cubed times 4/6 is 343 twelfths. 3.5 squared times 1/3 is 49 twelfths. And then we've got pi h. If we now subtract 343 twelfths from 120 and divide by 49 twelfths, we find our height to be 1097 over 49. Now y is our h plus r, so add 3.5 to this value and we get to 3 significant figures, 25.9. The diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. Assuming the volume does not change, explain what effect this would have on your answer to part A. Well, if we look at this shape, if this diameter got wider, but the volume remained the same, then this y value here would need to decrease. And so the answer obtained would decrease.